you can make it real.
And here we are with Mars Perseverance, 51 years later, getting ready to do the first ever Mars return mission.
Eventually, we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
In less than an hour, NASA's 300 million mile journey from America's shore to Jezero Crater on Mars will begin with the launch of this Atlas V rocket into space. And at the top of that rocket, with a beautiful sunrise and shrouded by that protective fairing, is the Perseverance Rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet. What a beautiful morning here on the Space Coast.
Ready for a great launch today. Thanks for having me on the show.
Man, happy to have you along, providing a ton of good context as we go through. Before we dive into the story of Perseverance, we want to give you a preview of what's ahead today in the countdown. Things really got going this morning just after midnight, actually, and Atlas V is just about ready to fly. In a few more minutes, we're going to get the final check of the weather, and that weather report should be coming back really positive. It's been great all morning. We have the terminal count ahead after that. We will be proceeding through the last few minutes of the countdown, and then the drama will be at its peak at launch when the clock strikes 0, the engines ignite, and the spacecraft and rocket take flight. After successfully passing through max Q just shy of 2 minutes into flight, the solid rocket boosters will be expended and will be jettisoned. Nearly 2 more minutes, and the payload fairing, what you might call the nose cone of the rocket, that has been protecting Perseverance, will no longer be needed. It will split in 2 halves and fall away from the accelerating vehicle. 1 minute later, the Atlas booster will have finished its task of lifting Perseverance above Earth's atmosphere and being on the way to orbit. It too will separate, exposing the Centaur RL-10 upper stage engine that will almost immediately begin its first burn that lasts approximately 7 minutes. After coasting for more than 30 minutes, the second burn, lasting around 8 minutes, will take Perseverance out of Earth orbit and into solar orbit on its way to Mars.
Mars exploration started in 1965 with the Mariner spacecraft flying by Mars. And in 1975, we actually landed the Viking 1 lander on the surface of Mars. And then after that, we started sending orbiters with more sophisticated instruments. Those instruments would do global mapping. They'd find the minerals. They'd find the topography of Mars. They'd actually study the weather of Mars. But we found out that those orbiters needed partners. They needed partners to go down to the surface of Mars and explore like a geologist on Earth would, where he walks around and takes pictures and maybe she takes some measurements. That's what these rovers needed to do, and that's really what started the Mars Rover program for us.
You know, we talk about being nervous and excited. This is right here where we're nervous and excited.
Yes.
There are a lot of things happening as we get ready to count down to the liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The fifth team, the one we haven't mentioned yet, is the Department of Energy, who is responsible for the MMRTG, the power source for Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, you know, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur, are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now, but again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post-liftoff, I want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show. There's a ton more content we have to bring you, and we are far from over. Want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up. There.
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is gone. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto sequence at T-minus 31 seconds. So that's a big thing that they're getting done here. At T-minus 25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
armed.
this mission.
SCS count
1
started.
minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Then valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for. The FTS system, there you see on your screen, a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable at
venting is
step
the
3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check. Go Atlas. Go Centaur. Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5,
5.
4. Engine ignition. 2, 1, 0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we have
the rocket.
One. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. And it's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed. A lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission, and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua, before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, and so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback, the Atlas is the quarterback's arm, Perseverance is the football, and Mars is the receiver.
That's exactly right.
And what we also talked about is that technically you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to get to Mars, because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months,
it's
right?
Tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually. Yeah. 25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now. And while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now. To recap, an Atlas V rocket carrying Mars Perseverance Rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the rocket took flight, it separated from the first stage and was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is. Much, Raquel. We are back here at the Kennedy Space Center with our most special guest, Moo, and the Perseverance Rover. Here it is, a full-scale mock-up of the actual rover itself. Well, Moo, here it is.
Yes.
And so we've learned a lot about this rover so far. So tell me, kind of describe from top to bottom what we're working here. At the top, you've got the mass cam, which is pretty tall, right?
It is very
it's
tall.
towering over your head. It is on a stage, but what does it do?
Yeah, so it has a lot of fun components. Some of them are the Mastcam Z. Z stands for zoom, so you see those two stereo cameras. And there's also that eyeball, what looks like an eye, is actually a laser. It shoots at the rocks.
A laser!
A laser, lasers! And then depending on the signature that comes back, the spectrometer reads it and tells you what the geology is.
And that's fantastic.
Yeah.
Some of the real exciting science, though, is happening right here on this part. This is the articulating arm that comes out, right, and then goes down onto the planet and starts drilling.
Exactly.
What all is here that's going to help us understand more about the geology of Mars, the climate, and whether or not there was life?
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill. The real drill will have a drill bit, a coring bit, which is hollow in the middle. And there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah,
here's
show
a
the camera
3D
there.
printed tube here.
Yeah.
And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, and there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest, and we're going to duck down. This is the Mars helicopter.
Yes,
and
Ingenuity.
Moo, this thing is going to be actually tucked up underneath the rover. It was a late addition to this project, but it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions. Yeah. It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look
right.
At the blades.
Wow.
These blades turn, right? And they turn in opposite directions.
They
I understand.
They do.
It will have a camera on it. It will shoot live or shoot video.
Yes.
That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour of the mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We are go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commence. Liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
On the other side of the Centaur burn and spacecraft separation, we'll also highlight 6 major technologies that NASA's focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur and Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done
and we have main engine
start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the direction we need to go, that fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together,
system is in
and
closed-loop control
we're hearing
as well.
Everything is looking nominal on this fire so far. Main engine start was good, and the firing is going well, nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me.
Yes.
He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here you should be seeing that engine cutoff, and that's completely expected. That's a nominal operation, as you say, Nick.
We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation, again, modified based on
the
data.
RL-10 shutdown.
That's great. Now, getting an acquisition of signal is a very significant moment. Can you tell us how it works and what we should expect to see for this mission?
Yes, that's a very important moment. And sometimes you'll see a spectrum graph that's a couple squiggly lines in the bottom, and what you expect to see is a peak in the middle come up, and that's what you call the carrier signal. And the carrier signal is described as a carrier because what it does, it brings in it brings in the signal. It carries the signal to us. Therefore, we can see that signal and know that we're receiving data. And basically, we see the carrier signal. But after that, we have to decode what the signal's saying. And hopefully what we're seeing is that the spacecraft is saying, hey, I'm doing okay. I'm on my way to Mars, and I'll see you there in 7 months. And so we expect to see that signal, and then we'll decode it and be able to get the health and safety of the spacecraft. But also what we'll also look out for is how to track it. So once we have the signal, we'll lock onto it. We'll move our very large antenna dishes, and as the Earth spins, we'll track the spacecraft around the globe. This is a global effort. We have our station in Canberra, Australia, and Madrid, Spain, and Goldstone, California, who will all be part of this tracking as the spacecraft goes to Mars. So very exciting time, and we're looking forward to hearing from Perseverance shortly.
Great. Thank you, Philip. Now, we are just a couple minutes away from the first opportunity we will have to see if the Perseverance signal on the Deep Space Network is up on our screens. That moment brings us one step closer to Mars, but we have many other milestones to hit over the next 7 months, and I'm with Perseverance's Chief Engineer, Adam Stelzner, who will tell us what's in store for the rover. Adam, what should we expect to see next?
Well, Raquel, we are... After we acquire signal, we have left the building. We are on our way to Mars. We're no longer in orbit around Earth. And what will happen next is we will start our cruise phase. It'll be about 7 months before we make it to the Red Planet. We have a set of planned trajectory change maneuvers that we do during cruise to adjust our targeting. In fact, we're targeting to miss Mars right now. We're on the way, general direction of Mars, but in order to make our Atlas Centaur, which threw us in the direction of Mars, not run into Mars, we're on a missing trajectory, and we'll do TCM1, which will target our impact with the Martian surface in a few days. So we start to monitor the spacecraft, make sure it's healthy and happy, and tweak its trajectory to be right on target by the time we make it to Mars.
Great. Thank you so much, Adam. And right now we are just a minute away from the acquisition of signal, so let's pause for a moment and watch our teams at work.
Today's flight will be waiting for indication of acquisition of signal. Ace copies.
M20, MEM redefined, report initial acquisition.
There we go.
That's it.
Copy that, Radio Science.
Flight nav. Go ahead, nav. We're seeing one-way Delta.
34 AOS.
Didn't copy, nav.
Yes, sir, we see AOS at 131531.
These copies, thank you.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from spacecraft and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
The biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given it.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
When you look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. Once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
And liftoff as the countdown to Mars continues. The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity. We've added to it a whole new set of science instruments, and these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
We now know Perseverance's place in history. Let's take an up-close look at the rover with Mars 2020 System Testbed Engineer Elio Morillo.
Thank you, Raquel. I'm standing in front of the Mars 2020 Perseverance scaled model. As you can tell, this vehicle is about the size of a Mini Cooper. These wheels are obviously black here and they look like rubber, but they're actually fully made of metal. These wheels are designed to allow us to climb over obstacles and of course climb over hills and minimize the amount of slipping once we're traversing on the surface of Mars. Here in the front of the rover, we have the sample caching system. And of course, at the very front end of this is the robotic arm, which this entire system is arguably the most complex robotic system we've ever sent outside of Earth. Here at the tip of the arm, we have a turret which contains a suite of instruments along with some drills and coring capabilities that will allow us to do contact science once we get to the surface of Mars. Not only that, this robotic system is equipped to collect samples about the size of a piece of chalk that then eventually will be stored inside of the vehicle and dropped off in a later location so that an eventual mission can go and return these samples to Earth, something we've never done in the past. Here in the front, we have the remote sensing mast. Something of note is that this mechanism is going to be stowed upon the touchdown on the surface of Mars. And one of the first critical activities we do is deploy this mechanism. This mechanism includes several cameras that are going to give us some of the most breathtaking images we've ever taken on Mars. Along with that, we have some lasers as well as a spectrometer. They're going to allow us to do some remote science. Here you see some of these extrusions that are part of a larger weather suite of instruments that will allow us to characterize the local climate around Perseverance. So that's a quick tour of the rover, but I gotta get back to work. So back to you.
telecom is confirming that the spacecraft has switched to broadcasting tones. These tones are received directly from Perseverance, but have very limited information content. We won't receive real-time information until about 9-10 minutes from now, once the Mars Reconnaissance Orbiter starts relaying information from Perseverance. We are under a minute from cruise stage separation, about 10.5 minutes from entry interface.
It's getting exciting. I have to admit, I am quite anxious, but very hopeful that this machine is going to do what we asked it to do.
You're seeing the heartbeat tones.
Okay, that means that there's no more ones and zeros coming. It's just the vehicle telling us it's still alive.
We're continuing to receive tones from Perseverance, standing by for cruise stage separation. We have indication that cruise stage separation has been confirmed by the spacecraft. It will separate the two balance masses that have kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We are about 7.5 minutes from entry interface.
Okay, the vehicle is pointed in the right direction. The thrusters are warmed up and doing their job. And now we've spun down from the 2 revolutions per minute that the vehicle had the whole way to Mars. It was a spin-stabilized spacecraft. And then from here on out, it's going to just be a bullet, and it's going to control its orientation and attitude via rockets on the back of that back shell.
Points carrier lock. The DTE from Radio Science from Green Bank reports carrier lock. Do you see the carrier on the downlink? Flight level 1.
We are continuing to wait for entry interface. We're about 6 minutes and 45 seconds from entry interface. We have confirmation from Greenback that they are receiving direct-to-Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report. This is as expected. We're currently just over 6 minutes from entry interface.
Okay, and now we wait. As soon as we get to the top of the atmosphere, it will be very quickly, which is the entry point. It won't be very long before the atmosphere will start getting thicker and thicker. It's going very quickly at a fairly steep angle of 15 degrees into the atmosphere, and as it starts to slow down.
We're just under, we're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, what we're looking for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio that's really designed to talk between spacecraft.
MRO reports the electro radio is powered on, ready to receive signals from the lander.
Okay, MRO is ready and able and waiting to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight local 1
from entry interface.
We don't need these ones and zeros, as Swati said, but to land safely. But we really need it for our own health and well-being today, to keep our nerves under control. But
around this time, a second spacecraft, MAVEN, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
Okay. Very soon we'll be getting ones and zeros, I hope, from our radio on the rover. The entry interface is nothing more than just an arbitrary place in the sky that we've defined to be above the atmosphere. But from that point on, there's definitely atmosphere, and above it there isn't.
We are 2 minutes from entry interface. Perseverance is to transmit heartbeat tones, indicating everything is nominal.
So the tones can tell us whether something's bad or not is happening. So far the heartbeat is doing well. So the vehicle thinks it's in good shape to land, which is a great sign.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry. We are 1 minute from entry interface.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
About seconds from entry interface. 5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The signal is now waiting until it begins feeling the atmosphere of Mars to slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost log.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes. 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 Yes.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target.
Parachute.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO is reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes, yes, yes.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Yes.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes, yes, yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface of Mars. Perseverance is continuing to descend on the parachute. we're coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers. We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have priming of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
As expected. As expected.
Sky crane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it.
Touchdown confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
Has been riding on this.
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready. We are ready, OL3. Go for it.
Wow.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
Just put the first image from Perseverance on the surface of Mars. Now it comes from the engineering cameras known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Look at that, right? You get the safe.
We just got our second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. So you can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together to do these kinds of things and make success happen.